Hello. I'd like to show you guys a weird coincidence that I found during the summer. So like if you want to just skip right to where the coincidence is, just like look at the timestamps, I'll put it there in the description below. But like if you don't mind sticking through the whole thing, like so we're all on the same page and stuff, I'll get to that right now. So you guys know, and this is a 2D coordinate planes where it's like the x-axis, y-axis and stuff. Now we'll make a unit circle on this 2D Cartesian plane. Cartesian coordinate system. There we go. You know what I mean. You know what I mean. You guys are smart. So this is our unit circle, and obviously, if you put a line from the center to here, this would be the radius, right? This is the radius r. So we'll go here, radius r. R would be equal to 1 here. R is equal to 1. But this, if there were to be some angle here, right? Like, well, let's zoom in a bit. If there were to be some angle here, right? This will be our theta. Then from this point, we could go down. Okay, it's not exactly like straight line here. I'll try to be better. Okay, just look pretend this is a straight line, okay? And this is a 90-degree triangle. So what we can do is we can use our good friends sine and cosine. And so here, let's label this length, right? So this length as y. And this length from the center to here as x. So normally to find the sine and cosine of some angle, like let's say sine of theta here, we would say it is the opposite of this angle. So instead of the adjacent, it's the opposite, y over the hypotenuse, or r, which also, funny enough, looks like an h. So I guess it kind of fits. So look at that, my terrible handwriting actually paid off for once. But because we know that in this instance r is equal to 1, we can just say that it is equal to the length y, right? To the length y. So on the y-axis here, there would be a point here, right? And once again, for our cosine of theta, that would be the x length. Normally it would be the adjacent or hypotenuse, but because the hypotenuse is 1, it's just the x length, right? So we've established here that there's a connection between the y-axis and the to sine, and x-axis to cosine, right? Like I think you see is that so far so good, I hope. So now we'll this is where the shenanigans will begin soon. So we'll drag this new little coordinate plane here, or we'll keep it here. Yeah, I think that's okay. So now we all know, I think so. Here, we'll put these arrows here. There we go. Oh, whatever, just there we go. That's good enough. So we know that this here, this whole length, so from negative infinity on this part to positive infinity to this part, this is the y-axis, right? It's y-axis. Oops, y-axis. And conversely, this whole thing from negative infinity to positive infinity here, that's the x-axis, right? Now, this is where we get to conjecture, okay? This is where we get into a bit of conjecture. And you'll see why in a minute, okay? So we'll get rid of this here. But instead of labeling this whole thing as the y-axis, what if we label from from 0 to positive infinity as the y-axis, right? So this will be the positive y-axis. Then same thing, but for the x. So from 0 to positive infinity as the x-axis. And you might be thinking, what am I doing? You'll see in a minute, okay? You'll see in a minute. Just trust me on this, guys. Then from 0 to negative infinity on this part as the negative y-axis. And once again, here, this will be our negative x-axis. So it's from 0, once again, to negative infinity. This will be our negative x-axis, right? I mean, so far, so good, I think. But now, here's where it gets tricky. All right, guys? Here's where it gets tricky. So instead of this being the negative x-axis, remember, we establish here that y and cosine have like a relation. So y to sine and cosine to x, right? So instead of this being the negative y-axis, so on and so forth, instead let's relabel them. And you might be thinking, well, what am I doing? What? This doesn't make any sense. Well, you'll see why. Because this will lead to a very interesting coincidence. So this is the sine. So let's say this is the sine, a positive sine axis. This is a positive cosine axis, right? This will be the negative sine axis, and this will be negative cosine axis. Now I've done this, and you might think, what is this? What's the point of this? This is ridiculous, right? But do you see the coincidence? If not, I'll show it to you here. So let's say we have some function f of x, right? F of x, and it's equal to sine of x, right? What's the derivative of this function? Well, we know that the derivative of f of x is equal, hold on, we'll draw that in a bit better, it is equal to cosine of x, right? F of x is equal to cosine of x. And the derivative of that is equal to negative sine x. And the derivative of that is equal to negative cosine x. Do you see the coincidence now? Like this can't just be coincidence, right? So we go because like normally the reason why like the derivative of sine is equal to cosine, there's like various sine properties, right? Like I think one of them is like sine of x plus h is equal to sine of x cosine of x, cosine of h plus sine of h cosine of x, something like that. Like don't quote me on that. And then there's like a whole geometric reasons for it. Like there's YouTube videos that explain that. But instead of that, it suddenly becomes a 90-degree rotation, a perfect 90-degree rotation. And I just think that is a interesting coincidence. But maybe it's not a coincidence. Like this is where I need to ask you guys. Like if you guys know, is this a coincidence? Am I just tripping here? Like I would love to know, because like I thought of this like this summer, right? I was just eating a burger and it just like popped in my mind. Ever since then, I just still randomly think about it. So I'd love to know if you guys know, if you guys have any answers, I would love to know. And yeah, that's about it. I'll see you guys on the next Random Rant.